In this video, we are going to look at an alternative way to think of the exponential growth model. We let n be the population size of some organism in a system. It could be any organism, cats, dogs, rabbits, or wolves. If there are no capacity constraints, that is, if there is an abundance of food and shelter, and negligible predators and disasters, then the rate of growth of the population is proportional to the population size. We can write this in the form of the equation dn over dt equals Rn, where r is a constant. To integrate this function, we first need to separate the variables n and t. We place the terms containing n to the left-hand side of the equation and the terms containing t on the right-hand side of the equation. Therefore, the left-hand side of the equation is 1 over n dn, and the right-hand side of the equation is r dt. Next, we integrate both sides. Since n, the population size, is a positive number, then the indefinite integral of 1 over n is ln n plus d, where d is any constant. Since r is a constant, the indefinite integral of r is rt plus e, where e is any constant. We can move the constant d to the right-hand side of the equation and combine the constant d and e to form the constant c. This gives us ln n equals rt plus c. In the next video, we will not write the constants d and e. We can just write a single constant after integrating both sides. Next, we exponentiate both sides. This gives us n equals e to the power rt plus c. We separate the constant c from the rest of the power to get e to the power rt e to the power c on the right-hand side. Suppose that the initial population is n0, that is, n equals n0 when t equals 0. Substituting these values into the equation, we get n0 on the left-hand side, and e to the power r times 0 plus c. This gives us n0 equals e to the power c. We substitute this into the equation for n. This gives us n equals n0 e to the power rt. Recall that this equation is the same equation for our exponential growth model. That is, when a population is growing at a rate that is proportional to its size, it is growing exponentially. In general, when we are given a rate of change of population that is expressed in terms of the population size, we can find an equation for the population size by setting up a differential equation, separating variables, integrating, and then substituting initial conditions.